Hello everybody, this is Tao Exam Coach. Today we're going to see another GMAT quantitative question. It is the question of the day by GMAT Club, which reads as follows. The sequence A1, A2, A3, and so on, A sub n, etc., is such that I times A sub I equals J times A sub j for any pair of positive integers I and j. If a sub 1 is a positive integer, which of the following could be true? And there are three following statements, the first of which reads 2 times a sub 100 equals a sub 99 plus a sub 98. The second statement says a sub 1 is the only integer in the sequence. And the third statement reads the sequence does not contain negative numbers. So we need to assess each of these statements individually, whether they might be true. If there is a possibility or just a single case where these statements can be verified true, so let's begin by evaluating the condition given about the form of the terms in the sequence. This general rule specifies a condition that all terms in the sequence must comply with. Based on this definition, if this is true for any pair of positive integers I and j, then it should be true for this pair of positive integers, 1 and j. So if this is true for 1 and j, then this means, according to the definition, that 1 multiplied by a sub 1 should equal j multiplied by a sub j. This for any positive integer j. So based on this definition, for example, if j were, say for example, number 5, if j equals 5, then it would be true that a sub 1 equals 5 multiplied by a sub 5. So it would follow that a sub 5, the fifth term in the sequence, would be a1 divided by 5. Similarly, if j were any other positive integer, such as, for example, 100, then from the same logic, a1 would be 100 or 100 times a sub 100. And therefore, a sub 100 would equal a sub 1 over 100, and so on. So now, with this, we can evaluate statement 1 first. In statement 1, we see the affirmation 2 times a sub 100 equals a sub 99 plus a sub 98. That is, 2 times the 100th term in the sequence equals the sum of the 99th and 98th terms, respectively. But according to this rule, any of these terms can be expressed in terms of the first. If we do the replacement of each of the terms mentioned in the first equality, we would have 2 times a sub 100, which would be a sub 1 over 100, and this would equal a over 1, or a sub 1, divided by 99 plus a sub 1 divided by 98. Notice that a sub 1 could be factored on the right side of this equality and cancelled with the term a sub 1 on the left in this form. And we would have what? We would have 2 over 100 equals 1 over 99 plus 1 over 98. But we can clearly see that this equality would be false. There is no chance that this is true. So statement 1 couldn't be true. What about statement 2? Statement 2 says that a sub 1 is the only integer in the sequence. Is this possible, that a sub 1 may be the only integer in the sequence? Let's analyze for a moment what would happen in case of having a sub 1 equal to 1. So in order to analyze this second statement, let's assume for a moment that a1 equals 1. Let's see where this assumption takes us. If a1 equals 1, then 1 multiplied by a sub 1, that is, by the value of 1, would be equal to j multiplied by the term a sub j. In other words, the value of this term a sub j would be this product here, 1, divided by j. But since, according to the definition of this sequence, j is a positive integer, then if you divide 1 by any positive integer different from 1, will always give you a fraction. For example, if j were 2, a sub 2 would be 1 over 2. If j were, for example, 5, then a sub 5 would be 1 over 5, etc. All other terms in the sequence besides a sub 1, or the first term, would be fractions. So in this scenario, a sub 1 would actually be the only integer in the sequence. So this statement 2 is possibly true. There is a chance that this affirmation holds true if we, for example, assume that a sub 1 equals 1. So in that sense, we need to validate this statement 2 as possible. What about the third one? In statement 3, it says that the sequence doesn't contain negative numbers. Well, is this true? Let's think for a moment that a sub 1 is a positive integer. We have this assumption here. A1 is a positive integer. So if A1 is a positive integer, notice that it needs to be true that 1 times a sub 1 be equal to j times a sub j for any positive integer j. But if a sub 1 equals a positive integer, then a positive integer multiplied by positive integer 1 would give a product that is positive. And consider this. If j is assumed to be positive according to this definition, if you have a product that is positive, and that means that if one of the factors is positive, the other factor has to be positive as well. This factor here needs to be another positive number. So if a sub 1 is positive, then any other term, all the values of a sub j need to be positive. So this confirms that the sequence doesn't possess any negative terms. So this statement here is always true. So statement 1 is always false. Statement 2, possibly true. And statement 3, always true. So which of the following could be true? The second and the third only. Option D is the correct answer choice. Thank you for watching and see you on the next video.